So as I was saying, we're going to combine our radicals with these complex numbers to look at more advanced methods of solving quadratics. So far, we've solved quadratic equations of the form x squared plus 6x plus 13 equals 1 minus x. We've solved them by setting them equal to 0 and factoring. So we could subtract 1 and add x to make the right side of this 0. So we have x squared plus 7x plus 12 equals 0. And that was factorable. X plus 3 and x plus 4 equals 0. And then we could split that into separate equations. Each factor had to equal 0. X plus 3 equals 0 or x plus 4 equals 0. And I'm going to assume you can solve those to get x equals negative 3 or x equals negative 4. But what if this didn't factor so well? How can we force it? Well, there were other methods that we did use to solve quadratics that were in a slightly simpler form. If I simply had something like 5x squared minus 7 equals 45, I would have to add 7. Oops. Let's try that again. Oh, let's see here. Let's do 73. Make that a little bit easier to work out. So we're going to have to start out by adding 7 to get 5x squared equals 80. And then divide by 5 to get that x squared equals 16. Now that we've got the x squared by itself, we could solve it using that square root method. And that square root method was just to take the square root of both sides of the equation. So the square root of x squared is x. Now we have to be very careful with this part. The square root of 16 is 4 or negative 4. We could have also solved that one by factoring. If we were to put the subtracted 73 from both sides, we would have had 5x squared minus 80 equals 0. And this could have been factored. It would have factored into 5 times x minus 4, x plus 4 equals 0. Would have given us those same answers of 4 and negative 4. But the square root method is a little bit simpler to do. It requires a little bit less work. We might have 5x squared plus 9 equals 179. So what are we going to do to solve this? Subtract 9. 5x squared equals 170. What are we going to do from there? Perfect. Divide by 5 to get x squared equals 34. And then square root both sides. X equals the square root of 34. Now we could calculate that out in our calculator to get 5 point something, or we've seen with our radicals, we can just leave it like that as the square root of 34. It can be a little more complex than that. We might have two x minus 5 squared equals 121. Now the square root or the squaring happened after other things did. In this equation, the squared was the first thing that happened to x, so it was the last thing we had to remove. Over here, squaring is the last thing that happens, so it's the first thing we have to remove. So we square root that. The square root and the squared cancel out. We get 2x minus 5 on the left side. What is the square root of 121? 11 or negative 11. Once we've done the square root, there are two possible answers. And anything we do from there, we've got to do with both of those possible answers. So 2x minus 5 equals 11. We'll solve that by adding 5. 2x equals 16, and then divide 2 by 2 to get x equals 8. On the other side over here, what do we have to do? Add 5 to get 2x equals negative 6, and then divide by 2. X equals negative 3. Now, anytime we have a square root or anything like that, as we saw before, that introduces a second answer, we should always double check to make sure both answers work. So we go back to this original equation. 2x minus 5 squared, does that equal 121? Well, if I put 8 in there, 2 times 8 is 16, minus 5 is 11. 11 squared is 121. So the 8 is good. Let's try negative 3. 2 times negative 3 is negative 6. Minus 5 is negative 11. Negative 11 squared is also 121. So the negative 3 works as well. So both of those are valid answers to that equation. Tell me what to do here. Perfect. Just like before we isolated the radical, here we're going to isolate the power. We're going to isolate the squared. We're going to add 93. So 5x minus 9 all squared equals 100. And then square root both sides. Now we're going to get two equations. What are they going to be? Good. Or negative 10, right? Now we solve both of those. Both of them we're going to add 9. In this case, 5x is 19. And divide by 5. X equals 3.8 here. On this side, we add 9. 5x equals negative 1. We divide by 5. X equals near negative 0.2. And once again, we should try those back in the original equation. So 5 times 3.8 minus 9 squared minus 93 equals 7. Let's check that out. 5 times 3.8 is 19 minus 9 is 10 squared is 100 minus 93 is 7. 5 times negative 0.2 5 times negative 0.2 is negative 1 minus 9 is negative 10 squared is 100 minus 93 does equal 7. So both of those are legitimate answers for that equation. So anytime we use that square root method, we have to make sure we're careful that we get both answers and we double check both of them to ensure that they are valid. Well, what if it isn't a perfect square? We can force it to be. We can start with something like this. Now remember, several weeks back, we looked at polynomials like this and we asked, what do we need to do to make this a perfect square trinomial? Remember what we did? Of course, the first term had to be x squared. We took the middle term and we divided it by 2 to get 3x. And then we squared that. 3x squared is 9. Oops, we don't need the x. We just take the value, the 6. Divided by 2 is 3. 3 squared is 9. 9 is the number that needs to go in there to make this a perfect square trinomial. Right now, this does not have a 9 in it. So what we're going to do is we're going to eliminate this term, get rid of it, by subtracting 3. Now note this is an equation, so I have to keep it balanced. I have to do the same thing to each side. So what I have over here right now is x squared plus 6x, and there's nothing right here. Equals 0 minus 3 is negative 3. Now, I want this to be 9 here. To make that 9, I have to add 9. After adding 9, I have x squared plus 6x plus 9 equals 6. At this point, I could not use factoring to solve this because it does not equal 0. But using the square root method, it doesn't have to equal 0 on the other side. This over here, x squared plus 6x plus 9, I know is x plus 3 squared. Remember, when you have a perfect square trinomial, it's the square root of the first term. The square root of x squared is just x. And the square root of the third term, the square root of 9 is just 3. And whether this is negative or positive tells us whether this is negative or positive. So now that we have that, x plus 3 squared equals 6, we can apply that square root method. So we're going to square root both sides. The square root and the squared canceled out. X plus 3 equals the square root of 6. Technically, I should write that as the positive or negative square root of 6, plus or minus. Now to finish solving that to get x by itself, I just subtract 3. X equals, usually I'd put the whole number first, so the negative, or the integer first, so negative 3, plus or minus the square root of 6. Yes, we can turn this into numbers if we want to. Negative 3 plus the square root of 6 is negative 0.5505. Negative 3 minus the square root of 6 is a negative 5.4495. Either one of those numbers, if I put them back into the equation, should give me a correct answer. Maybe off by some decimal places because of the rounding. Let's do another example of that is called completing the square. Which the name is kind of fitting because that's what we're doing, is we're creating a perfect square trinomial so we can make that perfect square. If I have x squared plus 8x minus 7 equals 0. So the first thing I want to do is get rid of that whole number piece, that integer piece there. It's a negative 7, so I am going to add 7. So x squared plus 8x equals 7. Notice I just left a blank there just to remind myself that I'm trying to fill in that blank, but really there isn't anything there. What do we need that number to be? Remember, the 8 tells us what we need there. We take that number divided by 2 and squared it. What's 8 divided by 2 and then squared? Careful. 16, right? 8 divided by 2 is 4. Squared is 16. So I heard somebody say 8. Sorry. So now, x squared plus 8x plus 16 equals 23. What does this left side become? X plus 4 squared. Good. So our next step is to square root. So x plus 4 is equal to plus or minus the square root of 23. Our final step, subtract 4. So x equals negative 4 plus or minus the square root of 23. I'm going to have you guys try one. X squared plus 12x plus 15 equals 4. I'll give you a minute or two to work through that, and then we'll go over. So subtract the 15. x squared plus 12x equals negative 11. What do we need this to be here? 36. So we add 36, x squared plus 12x plus 36 equals 25. What's this become on the left side? X plus 6. Good. And then square root. Good. X plus 6 equals 5 or equals negative 5. So subtracting 6, either x equals negative 1 or x equals negative 11. Both of those work in that equation. Now, the fact that those came out to be whole numbers should tell us something about this original equation. If I had solved this original equation for 0, we got x squared plus 12x plus 11 equals 0. That is factorable. What do you see that's different about this one? There's a 2 in front of the x squared. We haven't had that before. We don't like that. It can't be a perfect square trinomial with a 2 in front of the x squared. So what we're going to do is we're going to divide by that coefficient. I'm going to divide by 2. Notice every term in the whole equation has to be divided by 2. So 2x squared divided by 2 is just x squared. 8x divided by 2 is just 4x. 12 divided by 2 is 6. 0 divided by 2 is still 0. Now this looks like the ones we were working on before. What do we do next? Subtract 6. X squared plus 4x equals negative 6. And then what? This needs to be 4, so we just got to add a 4. So x squared plus 4x plus 4 equals negative 2. What's this become on the left side? X plus 2 squared equals negative 2. And then square root. So the square root of x plus 2 is the square root of x plus 2 squared is just x plus 2. The square root of negative 2 is plus or minus I times the square root of 2. If you recall from yesterday, we split that in the square root of negative 1 times 2. The square root of negative 1 is the I. We bring that out. Now, of course, to finish this, we minus 2. So x equals negative 2 plus or minus I times the square root of 2. Now the I, coming out with the I here, had nothing to do with the fact that there was a 2 on the x squared. I kind of added 2 levels of difficulty to this at the same time. The only reason that was is we ended up with a negative number on the right side. I'm going to have you guys try one in your notes, see how this turns out. I'll give you a minute to work on that one. Some of you may not be finished, but let's see how you're doing. First step, since there's a coefficient on the x squared, we're going to divide by that 5. That'll give us x squared minus 6x plus 12 equals 0. What's next? We subtract the 12, right? X squared minus 6x equals negative 12, and then what's this need to be? Positive 9. Even though this is minus, remember, negative 3 squared is still a positive 9. So x squared minus 6x plus 9 equals 3. Oh, sorry, negative 3. And then x minus 3 squared equals negative 3. Good. And then square root it. So the square root of x minus 3 squared is just x minus 3. The square root of negative 3 is plus or minus I times the square root of 3. And then add 3. So x equals 3 plus or minus I times the square root of 3. What do you think? Good stuff? The only place I really comes into effect is in electronics, in complex circuits. That's the only place I've ever really seen it in practical application. When you get into inductors and capacitors, there are real currents and then there are imaginary currents. So they affect the circuit, but they aren't really flowing. So our next step, let's look at a generalized way of doing this. If I have a general quadratic equation that is equal to 0, so the coefficient of the x squared, oh, come on now. Coefficient of the x squared is a, coefficient of x is b, and my constant is c, and it equals 0 on the other side. I'm going to go through the steps that I just went through to complete the square. First thing I did was divided by the a. So I got x squared equals b over a times x. X squared plus b over a times x plus c over a equals 0. The next step we did was we subtracted whatever was here. So I'm going to subtract that. Subtract c over a. So I got x squared plus b over ax equals negative c over a. Now to figure out what we need here, I'm using this coefficient here, b over a. If I divide that by 2, that's the same as taking it times 1/2. So that's b over 2a. Then I square that. B squared, of course, is just b squared. 2 squared is 4, and a squared is a squared. So what I need to add in here is b squared over 4a squared. Giving me x squared plus b over ax plus, yes, I know this is getting ugly. On this side here, adding those together, what I'm going to do is this. I'm going to turn this into negative 4ac over 4a squared. I multiplied by 4a on top and bottom. Now, they have the same denominator, 4a squared. So this is going to be negative 4ac plus b squared is just b squared minus 4ac over 4a squared. Anybody need me to pause so you can catch up? Okay, I'll give you a minute. Are you saying it's no longer better than a sharp stick in the eye? Once we get to the result here, life gets way easier, trust me. So this is just x plus b over 2a, all squared, equals b squared minus 4ac over 4a squared. I square root both sides. It'll cancel out the squared. So over here I have x plus b over 2a. Over here, I'm going to split this into the square root of b squared minus 4ac. On bottom, the square root of 4 is 2. The square root of a squared is a. But remember, that's still plus or minus. Now, we subtract the b over 2a. Well, these do have common denominators. They're both over 2a. So I've got negative b plus or minus that square root of b squared minus 4 over ac all over 2a. This thing might look familiar to some of you. As the quadratic formula. Those equations we've been solving so far can just be plugged into this formula. Notice what I did with this formula is I did the completing the square process with letters A, B, and C instead of numbers. So now all I have to do is take those coefficients A, B, and C and plug them into this formula, and it'll give me the answers to that quadratic equation. So if I have 2x squared minus 16x plus 15 equals 0. Notice, for this formula to apply, it must be equal to 0. So then A equals 2. B equals negative 16. And C equals 15. So we have to apply the formula twice. Remember our formula? Opposite B plus or minus the square root of B squared minus 4AC all over 2A. So B is negative 16. Opposite B is positive 16. Plus the square root of B is negative 16, so it'll be negative 16 squared minus 4 times A is 2 times C is 15 all over 2 times A is 2. Note that what we did there was the minus, or the plus. We'll have to come back and do the minus yet. So we're going to solve what we can here. Negative 16 squared is 256. 4 times 2 times 15 is 120. 2 times 2 is 4. I'm being a little sloppy with my order of operations, but nothing that'll hurt anything. So now we've got 256 minus 120 is 136. So that's 16 plus the square root of 136 over 4. The square root of 136. 136 can be split up into 2 times 2 times 2 times, oops, times 17, which means the square root of 136 can be written as, I take out the 2 2's and make it 1 in front, 2 times the square root of 34. I can divide out a 2. So that's 16 divided by 2 is 8, plus the 2 divides out, so that's the square root of 34 over 2. That's our first answer. Our second one's much simpler. The only thing that changes in our second answer is this becomes minus. Which means this is just going to be 8 minus the square root of 34 over 2. Those are our two answers. Now in the next example, I'll show you how we can leave the plus or minus in here and do them both at once. Any questions? Okay. Let's do another example here. 5x squared plus 30x plus 45 equals 0. What's A equal? 5. B equals 30. And C is 45. So opposite B is negative 30. Plus or minus, I'm going to put both of them in there this time. The square root of B is 30, so it's 30 squared. Minus 4AC, so that's 4 times A is 5 times C is 45. All over 2A, so that's 2 times 5. So inside the square root, we have to do the 30 squared, which is 900. And while we're at it, we're going to do the 4 times 5 times 45, which is also 900. On the bottom, 2 times 5 is 10. What this means, 900 minus 900 is 0. So that means the square root of 0 is 0. This is negative 30 plus or minus 0 over 10. Well, negative 30 plus 0 is negative 30. Divided by 10 is negative 3. Negative 30 minus 0 is negative 30. Divided by 10 is negative 3. A lot of people will mistakenly say that there's only one answer. There are 2 answers. They're just both the same. I know that's kind of a small little thing to pick on, but there are really 2 answers. They're just both the same. I'm going to have you guys try one. See how it goes. Give that one a shot. Now, before you get too far into this, what do you notice that I did slightly different here? It's not equal to 0, which means I have to make it equal to 0 by subtracting that 5. So that's where we're going to start out at. So b is 7, so this will be negative 7, plus or minus the square root of 7 squared minus 4 times 1 times negative 9, all over 2 times 1. Inside the square root, 7 squared is 49. Negative 4 times 1 times negative 9 is a positive 36. On bottom, 2 times 1 is 2. Still inside the square root, 49 plus 36 is 85. Unfortunately, the square root of 85 cannot be reduced. So our answer is negative 7 plus or minus the square root of 85 over 2. If you wanted to write that as negative 7 plus the square root of 85 over 2 and negative 7 minus the square root of 85 over 2, that's acceptable. But you can leave it just as 1 like that. What do you think? Not so bad so far? I'm sensing a lack of trust there. Probably rightfully so. Anyway, so let's try this one. So it's already equal to 0. I've done that. b is negative 2, so opposite b is positive 2, plus or minus the square root of negative 2 squared minus 4 times 3 times 11 over 2 times 3. Anybody have any questions as to how I'm getting these numbers here into the formula? Okay. So now, inside the parentheses, or inside the square root, I should say, the radical, negative 2 squared is 4, minus 4 times 3 times 11 is 132. 2 times 3 is 6. Here's where the issue comes up. 2 plus or minus 4 minus 132 is a negative 128. The square root of a negative 128 needs to be explored a little bit. I'm going to break that down into the square root of negative 1 times 2 times 2 times 2 times 2 times 2 times 2 times 2. In other words, it's negative 1 times 2 to the power of 7. Which means, of course, I can bring the negative 1 out to make it an I. 2 to the 7th, I'm going to break it into 2 to the 6th times 2 to the 1, or just 2. So I'm going to leave a 2 inside the square root. 2 to the 6th is going to come out and be 2 to the 3rd. Remember, we divide the power in half with the root. 2 to the 3rd is just 8. So this is 2 plus or minus 8i times the square root of 2 over 6. Not quite done yet. Can anybody tell me what still needs to happen? Each of those divides by 2. So it's 1 plus or minus 4i times the square root of 2 over 3. What do you think? Not horrible? Can we keep the sharp sticks in the closet for now? So that is, of course, our official quadratic formula as we've been using the last few examples. But there is one part of that quadratic formula that's more important than the others. This part right here. B squared minus 4AC. We give it a special name called the discriminant. We actually saw 3 different cases up above. Case 1, that discriminant was positive. We had 2 real answers. Most of the time those answers took the form of, there was a radical in there, like this. Negative 7 plus the square root of 85 over 2 and negative 7 minus the square root of 85 over 2. That was when that discriminant was positive. Case 2, that discriminant was equal to 0. Now some would say that it was just one answer. Remember, it's really 2 that are the same. We had the 3 both times. Actually, I believe it was negative 3. The third case is if that discriminant is negative, which is what we just had right here. What was inside that square root was negative. And that gave us still 2 answers, but they were complex. If the original equation is factorable, that discriminant will be a perfect square. Like 16, 121, 576. It'll be a number that when we square root it, we get a perfect square. We don't have a radical or a decimal or whatever left in it. So that discriminant tells us a considerable amount of information about our equation. To use the discriminant, it still has to equal 0, but our discriminant is b squared minus 4ac, so it's going to be negative 16 squared minus 4 times 2 times 32. Negative 16 squared is 256. 4 times 2 times 32 is 256. That discriminant equals 0. Which means both answers are going to be the same. And they will be integers. There won't be a radical in it. Here our discriminant would be 3 squared minus 4 times 5 times negative 17. 3 squared is 9. 4 times 5 times negative 17 is a positive 340. That adds up to be 349. Well, that is not a perfect square, but it is positive. So that tells us that we are going to have 2 radical answers. They'll be real numbers, but they're going to have roots in them, a square root in them. Make sense? Okay. Now, foreshadowing a little bit to next week. Equations that are in quadratic form. So far what we've had is just quadratic equations, but we can have equations in quadratic form. Like this. Not x squared here, I actually want to put x to the 4th plus 8x squared plus 6 equals 0. This equation is in quadratic form. What I mean by that is that there are only 2 different powers of the variable. Of course, there's only one variable. It's either x or whatever. It could be y, z, u, whatever. And the largest power is 2 times the smallest. So this is x squared, this is x to the 4th. The x to the 4th, the 4 is 2 times the squared, the 2. To solve that, we're going to use a substitution. It's often called a U substitution if you're in calculus. You can substitute pretty much anything you want into it, really. But we're going to do this, is we're going to let U equal x squared. So what that means is this becomes U squared plus 8U plus 6 equals 0. Now I can solve that using the quadratic equation. Negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 6 all over 2 times 1. This is negative 8 plus or minus 8 squared is 64 minus 4 times 1 times 6 is 24. 2 times 1 is 2. This is negative 8 plus or minus the square root of 64 minus 24 is 40. The square root of 40 can be reduced to 2 times the square root of 10. We can divide out the 2. Gives us negative 4 plus or minus the square root of 10. So u equals negative 4 plus or minus the square root of 10. But remember, u really equals x squared. So x squared equals negative 4 plus or minus the square root of 10. To really solve for x, I have to take the square root again. So x equals positive or negative square root of negative 4 plus or minus the square root of 10. Now that's just a tad ugly. So let's take a look at one that works out a little bit better. Let's look at this one. So again, we're going to let u equal x squared. So this becomes u squared minus 3u plus 10 equals 0. Oops, I screwed up. This should be minus 10, not plus 10. So now, you could actually factor this, by the way. This does factor into u minus 5, u plus 2. And you could solve it from there. Let's go ahead and use our quadratic equation. If at any point you do see that these equations can be factored, please feel free to factor them. You don't have to go through the quadratic equation. So anyway, this will be 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 10 all over 2 times 1. This is 3 plus or minus the square root of 9 plus 40 all over 2. This is 3 plus or minus the square root of 49 over 2. This is 3 plus or minus 7 over 2. Of course, 3 plus 7 is 10 over 2, which is 5. 3 minus 7 is negative 4 over 2, which is negative 2. But remember, this is still u. U equals 5 or u equals negative 2. If we put x back in, x squared equals 5 or x squared equals negative 2. We have to solve each of those by square rooting. X equals plus or minus the square root of 5, or x equals plus or minus I times the square root of 2. What do you think? I hate to leave you hanging over the weekend on that note, but we will start on Monday with this stuff and, of course, go into more detail on it. For now, remember homework 13, A, B, and C is the material we covered this week. The stuff we covered today is specifically 13C. And of course, quiz 13 needs to be completed by the end of the day Monday. You guys have a great weekend.